From Tycoon U Studios in Delray Beach, Florida, this is Options GPS with Chris Rowe and Ron Ianieri.
And welcome back to Options GPS. I'm Chris Rowe.
And I'm Ron Ianieri.
And now that we covered Delta, and hopefully you've gone back to the community, you feel nice and comfortable, you've talked to some of your peers about it, you're ready to start hitting up what we're going to talk about next, which are
the strike-based Greeks, with Gamma being the first one.
Very good. And the strike-based Greeks, let's talk about why they're just a little bit different from the other ones that we've talked about.
Well, it's a little different in the sense that the strike-based Greeks, Gamma being one of them, is actually calculated through the model by strike. And that means that an option with the same month and strike, two corresponding options, a put and a call, will have the same Gamma as each other. Now, when you look at Delta, Delta is actually calculated by option. That's why we have calls with long deltas, puts with short deltas. Delta almost discriminates, in a sense, between call and put. Gamma, as a strike-based Greek, doesn't. It doesn't care about call and put. It simply cares about what's the month and strike. That's the way it's calculated through the model, and that's why corresponding options, a put and a call of the same month and strike, will have the same Gamma.
They're equal opportunity Greeks.
They would be equal opportunity Greeks if you want to look at them that way.
They don't discriminate between calls or puts.
Nope, they don't. And the nice thing is this starts to show how calls and puts are actually more alike than unalike.
All right.
Or disalike.
Well, let's talk about it. Let's talk about Gamma. Why don't you go up there and just show everybody what you've got to say.
Let's get started with Gamma.
Let's rock.
Let's now turn our attention to Gamma. Now, Gamma is going to be one of the Greeks that I'm going to refer to as a strike-based Greek. Delta actually sees the difference between puts and calls. As we know, Delta is positive for calls, negative for puts. So in a sense, Delta does discriminate between puts and calls. However, our other Greeks coming up are strike-based. That means that these Greeks don't see a difference between put and call. They're calculated by month and strike. When you think about what that means, it means that two corresponding options, a call and a put, with the same month and same strike, are going to have the same Gamma, and they're going to have the same Vega and Theta. We're going to be talking about Vega and Theta later. But let's start off with Gamma, the first of our strike-based Greeks. Gamma is known as the second derivative. It's the second step from the underlying. What do we mean by the second step? Well, we know that delta measures the direct relationship between the movement of our option and the movement of the stock. However, as the stock moves, delta changes. The second step is not the movement of the stock, but the movement of delta. The second derivative is gamma. It measures how our option's delta changes with the movement of the stock. So when you think of the term delta, delta meaning rate of change, gamma shows us the delta of the delta, the rate of change of delta. How is delta going to change as the stock moves? You might wonder why that's important. Well, obviously, if the stock moves and delta changes, then your position could change. You could become longer or shorter than you had anticipated being just because the stock has moved. Now, obviously, we saw how Trumpification changed deltas. Remember, Trumpification told us what? That the in-the-money options, we're going to lose delta over time. Out of the money options, we're going to gain delta over time. And that was going to happen through either the passage of time and or movements in volatility. Now we're going to see how the movement of the stock changes delta, and that is gamma. Two types of gamma that we have to concern ourselves with. One is long gamma. We acquire long gamma whenever we purchase an option. Doesn't matter if we buy a put or a call. If we buy an option, we have long gamma. Short gamma comes from selling options. Whenever we sell an option, put or call, we will acquire short gamma. Now, obviously, short and long gamma are different because of their effect on delta. And we'll go over that in a couple minutes. Like delta, gamma can be a summation of all the gammas of all the options that we're looking at. Unlike delta, stock does not come into this equation. Only options have gamma. So when we're looking at our total position gamma, we're talking about the gamma of all of our long puts and calls minus the gamma of all of our short puts and calls under a specific stock, the total of it. Summate, and boom, you've got your total position gamma. So we can know the position gamma of not only one single stock with all of its options, but also a gamma of our entire portfolio. Gamma can be summated. So when we look at the position delta, we know that we can, what? Look at it for an individual option, we can look at it for everything under an individual stock, or we can look at it for an individual entire portfolio. Gamma works the same way. We can look at an individual options gamma, an entire positions gamma, or even an entire portfolio's gamma. So when we're talking about position gamma, we know we're either going to be long or short. And that long or short is going to be determined by adding up all of the gammas under that single stock. Now what we need to look at is how does gamma work? How does it operate? When the stock goes up, what happens to my delta position? Why does gamma increase it or decrease it? What happens if I'm short gamma? Why, if the stock moves up $1, why did my short gamma change my deltas in this way or change my deltas that way? Here's how gamma works. Remember this chart? You saw this with delta, didn't you? And this is a chart where our current stock price is $50. We've got our nice bell curve drawn directly over the stock price. And what we're going to do now is we're going to start moving the stock and watching how the delta changes. Keep in mind while we're doing this, delta's definition as percent chance. It'll be a lot easier. So right now, it's 50-50. And let's pretend we are talking about the at-the-money call, the 50 delta call, stock trading at 50, 50 delta option. We know that it's a 50-50 chance that the stock can either go up or down from 50. That's why half of our graph is colored in red, the other half is empty in white. The stock has an equal ability to go up as it has an ability to go down, and in the same amount. That's why this is symmetrical. We know this all from our review, because we were reviewing random walk, right? Okay, so let's move the stock and see what happens to this colored part. As the stock went up $1, we see that our total colored area is now bigger than half and half. Why? Because now with the stock at 51, the 50 strike is now $1 in the money. It's not sitting directly on the fence. It's already over the fence on one side. Thus, the stock has what? A 50-50 chance of going either direction again, but if it goes down, we still are at 50-50. It goes up, our odds of this option, the 50 strike, has increased. Now it's no longer 50-50. So what has gamma done for us? Gamma has shown us that when the stock moved up, the percentage chance of our 50 strike finishing in the money has increased, as you can see by the total colored in area. How much has it increased? That's what gamma tells us. And that's that shaded area in blue there. We have acquired this much additional delta. Why? Did we buy more stock? Nope. Did we buy another round of options? Nope. Then how did we get more delta? Through the gamma. That's how we got more delta. Gamma acquired it for us. Gamma increased our total delta this much, the area in blue. Let's say the stock goes up again, this time to 52. Again, our odds of success on this 50 strike call have increased. We're already $2 in the money. By expiration, we've got a much better chance of this option remaining in the money because it's already in the money. Even if it traded down a bit, we still have the opportunity for our 50 strike to remain in the money. So obviously, with that increase in percentage chance due to the stock movement, we have an increased delta. Did we buy the stock again? No, of course not. We didn't add more options either. This is simply the movement of the stock increasing the percentage chance or delta of this option. The first movement increased the delta by this blue area. The second movement also increased delta, this time by this yellow area. What do we notice here? Although our delta has increased, it has increased less this time. The blue area is larger than the yellow. What is that saying? Well, when the stock was directly at the money, it had a larger gamma. Now that the stock is moving further in the money, it's having a lesser gamma. Delta has still increased. Our area is still bigger, but it just hasn't increased as much as we saw in the first movement. How about we move it again? Now the stock is at 53. Of course, our bell curve is centered directly over the current stock price, and you can see that our 50 strike now has a very high chance of finishing in the money. We've added more percentage chance, this area in the green, from when we went from 52 to 53. Each dollar movement increased the overall delta by the amount of gamma. But the difference each time is each movement away from the at the money, although still increasing the delta, the gamma didn't increase it as much. The gamma has gotten smaller. What you're going to see is gamma is always highest at the money. This will be true for all the strike-based Greeks. As we get further in the money, like we see what's happening right now, we own the 50 strike. We were right at the money when we started. Then we were $1 in the money. Now we're $2 in the money. Finally, we're $3 in the money. The further in the money we get, the less the gamma affects the delta, because the further in the money we move, the smaller the gamma. If we moved again, you would see that only a portion, a smaller portion of this bell curve would be filled in. The reason is because of the shape of the bell curve. As we add to the percentage chance, each additional addition only creates a smaller increase in percentage chance. What about the other way? Does it work for puts? Of course it does. Stock moves down to 59, we own the 49, we own the 50 strike put. When we started, it was 50 deltas. Now that the stock moves down $1, our 50 strike put is now in the money by $1. Its percentage chance of being in the money at expiration has increased. How much has it increased? This blue area. Did this delta increase because we bought more stock? No. Did the delta increase, or sold more stock actually, because it's a short side? Did the delta increase because we bought more puts? No. We did nothing to make us shorter. Gamma acquired more deltas for us. How much did it acquire? It acquired this whole blue strip. Now we have a bigger percentage chance of success in our 50 strike put, being in the money at expiration. Let's move the stock again, down to 48. Now, as you see, bell curve is still set up over the last sale. Stock is now what? 48, which is now $2 in the money off our 50 put. We have a bigger area of percentage chance. It means that we have more potential chance of success that this option will remain in the money. So with a higher percentage chance, the delta has increased. But we didn't pick up as much delta this time as we did on the first movement. The first movement from 50 to 49, we picked up this blue area. Now from 49 to 48, we only picked up the yellow area. You're seeing the same exact effect in the puts as you saw in the calls. Why? Because gamma is strike-based. It doesn't see a difference between put and call. It's calculated by strike. Corresponding options, a call and a put with the same month and strike will have the same gamma. That means this effect holds true to both puts and calls. Remember I said that the mechanism of how puts and calls work is actually identical. That's why I find it hard to believe that people can trade calls no problem and they get all screwed up with puts. Same mechanism. One more movement, what do you think? There's our final movement. What happened? Now our option is already $3 in the money. Even a higher percentage chance that this option will finish in the money at expiration. That's obvious from the area that's all colored in now. There's only a small little bit chance that we might wind up out of the money. So we've increased our delta again. We've increased our percentage chance one more time with another dollar movement in the stock. But look, although the percentage chance has increased again, it hasn't increased as much as the previous two. What is that saying to us? The further we move from the at the money, further in the money we go, the less gamma increases the delta. That means a smaller gamma. So what we want to do is we want to take a look at the gamma graph. The same way we looked at the delta graph. We need to know where gamma is most sensitive and where it's least sensitive. Because when we're in a position, we need to know, am I going to be in an option that is highly sensitive to the movement of the stock? Or is it less sensitive to the movement of the stock in terms of the delta changing? And we're also going to look at the graph and look at the difference as time changes. Gamma changes with time also. And finally, we're going to take a little look at gamma trading. But let's look at this chart here. One thing that's important to note, gamma is given in deltas. Gamma is given in deltas. Gamma tells us how many deltas our option will change with a $1 movement in the stock. So these are not dollar prices. These are not percentages. Gamma is given as deltas. Let's take a look at what I mean. Take a look at the June 65s here. As you know, I did not say put or call. Why? Why didn't I say this is a put or call? Simple. Because gamma is strike-based. It doesn't see the difference between put or call. The June 65 put and the June 65 call will have the exact same gamma. So let's take a look at the June 65 strike, hence the term strike-based. 7.2. That 7.2 is 7.2 deltas. Gamma is given as deltas. That means for every dollar movement in the stock, this option's delta will change 7.2. What does that mean? Well, we remember the delta of this option, don't we? It was around 50, the at the money. Actually, I think exactly the call was 56 and the put was 44. But let's just round it to 50 to make the math easy. If the stock were to go up $1, my 50 delta option would now be a 57 delta option. That's what gamma is telling me. Now that the stock moves $1, what's the new delta of my option? In this case, my new delta will be 7 deltas higher than it was with the $1 movement of the stock. Over here, October 75s. If I own the October 75s, my gamma is about 3. That means that my delta will change 3 deltas for every dollar movement in the stock. So if I have a situation where I've got this option and the stock trades up $1 and this was a 30 delta, up $1, I could look for this option to now be 33 deltas. Vertically, how does gamma look vertically? Well, let's take a look here. Remember our chart and our little concept that we just went over with as the stock move, less and less of the area percentage chance increase? What do we have here? We know that the first movement away from the at the money was the biggest change. And as we got further and further away from the at the money, the change decreased. Let's take a look. At the money, we know that the stock was around 65.50 when we took a look at this. The at the money options, 65.70. Look what we have. But now let's look as we go further out of the money. Decrease. Further out of the money. Decrease. What about in the money? Decrease. 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 What does that tell us? When we look at any given month, gamma is always biggest in the at the money strike. Gamma is the biggest at the money. And it decreases as we move away from the at the money strike in either direction. So if I have a position where I want to have a lot of gamma, what option am I going to look to buy? The at the money. So right off the bat, I know where to go because I understand a little bit of the basic characteristics of gamma. I know that I've got big gamma here at the money. And I know that gamma decreases as I move in either direction away from the at the money strike. What else does it tell me? If I originally buy an option that's in the money, I might have very little gamma. But if the stock starts trading down toward my strike, where my strike that was in the money is now becoming at the money, what can I look to gamma to do? Increase. Because where it was in the money and small, as the stock approaches that strike is no longer in the money with a small gamma. It's going to be at the money with a gamma looking more like this. So as the stock moves, we also can see how our gamma changes. So when we are looking at our position and the stock moves, gamma is telling us how much our delta is going to change, but we also have to realize with the movement in the stock that our gamma is going to change. Now, you don't have to sit there and calculate this stuff by hand. I don't expect you to stay up to the wee hours in the morning with a protractor and a compass and a slide rule trying to figure out what the doggone gammas are going to be. That's ridiculous. Your platform does this for you automatically. It does it in real time. You don't do any work. We're talking about this because I want you to know the concept behind your changing number. What does that number mean? How does that number react? Well, if you don't understand this, you're going to be given a number that's meaningless because you won't know what to do with it, how it's going to change, when it's going to change. Now, vertically we know gamma's biggest at the money. That holds true in every month. Second month, gamma at the money, move out of the money, it gets smaller. Move out of the money the other way, it gets smaller. Next month, gamma biggest at the money. There in October. Move in the money, it gets smaller. Out of the money, it gets smaller. Finally, January. Although not by much because we're getting a crunch, aren't we? If the deltas are crunching, the sensitivity of those deltas is also crunching. And that's shown in our gammas. Look at the crunch. They've tightened up. We still have the highest at the money. And we eventually start decreasing as we go further in the money or further out of the money. So we have a good idea. Gamma is highest front month at the money. As we go out over time, gamma decreases. As we move in either direction, gamma decreases away from the at the money, further in or further out. Now you might say, wait a second, Ron. Whoa. See, you've got a keen eye because you just caught something. You noticed that in the at the monies, the gamma decreased as we went out. But when you looked at the in the monies, they're increasing, aren't they? And when you looked at the out of the monies, they're increasing also. Why? Because when we're looking at these in-the-money options with very little timed expiration, what are these options trading like? They're trading like stock. Remember, these were 100 delta? They're going to mimic the stock 1-to-1. These two options are losing their optionness. They're actually turning into stock. Stock has no gamma. But as we went out further in time, these options started picking up delta. They started to get more of their optionness together, and gamma started reappearing in them. If we go out far enough, you'll even see these numbers start to tail off. At the beginning, this isn't even an option anymore. This is stock. You talk to any trader on the floor and say, hey, how about those June 50s? They'll be like, what June 50s? It's stock. That's what they'll say. They won't say, oh, it's acting like stock. They will tell you it is stock. And if it is stock, it can't have any gamma. As we go further out in time, remember, these options started losing delta. As they lost delta, they lost their direct relationship to the stock. They became options again, and they started acquiring gamma. If we went out to 2080, we would see that the gammas of these things would start turning down. Same in the other direction, the out of the monies. As we can see, the gamma is actually increasing here. But in these, you can even see where it's starting to tail off. The next one out would probably be 1.7. Further out, 1.5. It's going to take a little time for these options. What is this option? That 80 strike. Remember with calls, 0 delta? With puts, 100 delta? This 80 strike is a call. It doesn't exist. It's 0. However, with more time, remember its delta was increasing. With more time, it was starting to become an option again. And what happened? As it started becoming an option again, it started acquiring gammas. But soon as we got out far enough, these gammas start tailing off again. So it's important to remember, gamma is highest front month at the money, lower as we go out over time, decreasing as we go away from the at the money strike in either direction. Now what we want to do is take a look at how gamma works. Here's a chart of how gamma works. We've got a position down here. We're going to be long 1,000 shares at 55. We're going to be long 20 of the May 55 puts. They are going to be what? 50 delta, right? May 55 put with the stock at 55. At the money, actually directly at the money, 50 deltas. And we're going to have a total delta at 55 being 0. Why? Because if I'm long 1,000 shares, each share being 1 delta, and I'm long 20 of these negative 50 delta puts, then I've got 1,000 long, which is plus 1,000, and 1,000 short. 20 puts times the minus 50 deltas for each, minus 1,000. I really have no delta here. For you stock traders, it's like having 0 shares. So you stock traders would say, well, if I don't have any shares, then I've got no position. Correct. But we're not talking about stock trading. We're talking about option trading. You see, I do have a position here. Where I don't have a delta or equivalent stock position, I do have a gamma position, right? I bought options. When I bought those options gave me gamma, long gamma. And I'm going to show you how long gamma works first, so that you know, rule of thumb. Whenever I say rule of thumb, grab a paper and pencil and write it down. When I am long gamma, repeat, when I am long gamma, when the stock trades up, I acquire more long deltas. So when I'm long gamma, stock trades up, I acquire long deltas. In the opposite direction, when I am long gamma, when the stock trades down, my gamma position acquires me short deltas. Let's take a look at that. Let's say the stock trades up $1 to 56. What do I know about gamma and what it tells me? Gamma tells me how much my delta changes with a $1 movement in the stock. So, if I have 250 gamma and the stock trades up $1 to 56, that gamma is going to acquire me 250 deltas. Now, knowing that long gamma acquires long deltas when the stock trades up, those 250 deltas are going to be 250 long deltas. So at 56, suddenly the position that I had that said 0 delta at 55 is now long 250 deltas, or 250 equivalent shares. How did that happen? I didn't buy any more. Did you buy more? You didn't buy more. I didn't buy more. You didn't buy more. Who bought more? Gamma did it. It was the butler. Gamma did it. Gamma acquired us these deltas. How'd he do it? Let's take a look. When we go up to 56, we see our shares, 1,000 long shares, are still 1,000 long shares, aren't they? If I buy 1,000 shares at 55, stock goes to 56, I still have 1,000 shares. Those long 1,000 shares up at 56 are giving me long 1,000 deltas. But something has changed in the options. You see, now, instead of these at-the-money puts being short 50 deltas, they're no longer short 50 deltas. Because with the stock moving up $1, those puts aren't 50 deltas anymore. They've lost deltas. Their percentage chance has decreased. The deltas of those puts have decreased to 37.5. So now, 20 of them times 37.5 gives me a negative 750 deltas. Positive 1,000 deltas for my stock position. Negative only 750 deltas now for my put position. That leads me to what? Being now long 250 deltas. The thing about how gamma works and does this all is that my option position's delta changes with movements in the stock. And with that movement change and the change of the deltas, my position has obviously changed. These puts were 50 delta right here. They were directly at the money. Moving up $1 took away some of their deltas. There's a smaller percentage chance that they'll be in the money now. Now their delta is only 37.5. So if their delta is 37.5 and I own 20 of them, where before there were 50 deltas and I own 20 of them, giving me a short 1,000 deltas here, which perfectly offset the long 1,000 deltas of the stock, I don't have the perfect offset anymore. I don't have 50 deltas giving me short 1,000 deltas for my puts and making this 0. Short 1,000 deltas from the puts, long 1,000 deltas from the stock, it would have been 0. That's not true anymore here. Here, these puts are only 37.5 deltas. Times 20 of them only gives me a short position of 750. Combined with the 1,000 long shares, now I've got a delta. I didn't have one when we started, but I've got one now. So when the stock got up to 56, although it did not affect the delta of the stock, it did affect the delta of the puts. So my 1,000 shares, no matter where the stock goes, remains. If I don't sell it, then it doesn't matter whether the stock goes to $1 billion. I might have a huge profit if it went to $1 billion, but I still only have 1,000 shares. That means those 1,000 shares always translate to only 1,000 deltas long for my long 1,000 shares. So what's happening here is there is a variable. This is fixed. The stock position is fixed. However, the variable is the option. It's delta changing every time the stock moves. At the money, the delta of the puts was 50. $1 up, the delta of the put has decreased to 37.5. When I times that by my 20 puts, I only have 750 short deltas against my long 1,000 shares. I suddenly am long delta. That's how that worked. Because up here, and the further up I go, what do I know about the delta of my puts? As they get further out of the money, that delta continues to shrink. Right now, here, that delta is 37.5. Why? Because if my gamma is 250, simple math, really, if my gamma is 250, and the stock trades up $1, I know that it's going to change my delta by 250. If that's true, and up $1 I'm long 250, we know that the stock couldn't have moved. The delta of the stock remains intact. This must have moved. How much? Well, if I have a total delta of 250, 1,000 long delta in my shares, I have to have an offset or a negative delta position in these puts of 750 negative deltas, because that would be 1,000 long shares plus minus 750 delta in my puts would give me a long 250 delta. I've got 20 of these puts that add up to a negative 750 deltas. 750 divided by 20, 37.5. That's how I knew that the delta of these puts was 37.5. One thing you're going to start to realize is that options are mathematically based. There is a formula to all of it. It all adds up. Whenever you're dealing with an option instructor, when they say something, they better be able to prove it mathematically. If they can't prove it mathematically, they're either truly not an expert, because an expert can show you the math behind this, because it is mathematically based, or they're lying to you. One or the other. But everything they say, they should be able to prove mathematically. That's how gamma, long gamma, works. That's why when the stock goes up from 55 to 56, I pick up long 250 deltas. Why? Because I lost 250 short deltas from my puts. They used to give me 1,000 short deltas. They're now giving me only 750 short deltas. I got longer because my puts lost negative delta. Not because my long delta stock increased. It didn't. I got longer because my puts short delta decreased. There's the equation. Very simple. Up at 56, 1,000 long shares is 1,000 long delta. My puts now are only contributing a short 750 deltas. That's why I'm being left with a long delta position here. What happens if the stock goes up another $1? It goes from 56 to 57. We know that our stock, the 1,000 long shares, is 1,000 long shares still. But remember the dollar movement and how it affected the put delta? Now we've got another dollar movement. It's going to affect the put delta again. We were a negative 50 deltas right here at the money. Then we went to only a negative 37.5 deltas, up $1. Up another $1, we know our put delta is going to decrease again. We're going to be less short in our puts. And with being less short in our puts, the delta we're getting from the stock is now heavier. Up here. Let's see what happens. At 57, the delta of our May 55 puts will have decreased from 37.5 at 56 down to 25. You might say, Ron, how do you know it's 25? Math, right? If I'm long 1,000 shares still, and it's giving me a total delta of long 500. I know that my put position must add up to a minus 500 deltas. Long 1,000 deltas through 1,000 shares, minus 500 deltas through my puts would give me a positive 500 deltas. So I know that my puts, these May 55 puts, are going to be a total of a minus 500 deltas. If that's true, and I have 20 of them, 500 divided by 20 is 25. So my 1,000 shares is 1,000 deltas still. But the difference is my puts. As the stock traded up, my puts lost delta. As they lost delta, their shortness decreased. They became less short. They're falling behind keeping up with the stock. So now I have a position that's long 1,000 shares of stock, giving me long 1,000 deltas, but I now have only short 500 deltas from the puts. 20 of them times a minus 25 delta. So I'm long 1,000 minus 500. What do I have? I'm long 500 deltas here. As the stock is going up, my long gamma is increasing my delta position, getting me longer delta. Remember, long gamma, when the stock goes up, gets me more long deltas. It's getting me more long deltas. How many long deltas? What's my gamma? 250. What does it say? Long gamma will increase my long delta as the stock goes up by the amount of gammas per dollar. Remember, gamma tells us how much our delta will change with a $1 movement. We went up $1, we added on 250 deltas. That's our gamma. We went up another $1, we added on another 250 deltas through our gamma. Why? Because 250 tells us what? A $1 movement. How do we find out a $2 movement? 250 times 2. 500. That is how gamma works, long gamma works to the upside. We also have the downside to consider. We know that when gamma is long, and we are in long gamma, when gamma is long and the stock trades up, it increases our long delta. However, when the stock trades down and we're long gamma, it makes us shorter delta. Mechanism works the same way. Let's have the stock trading down $1 to 54. Our 1,000 shares that we bought at 55 is still long 1,000 shares at 54. We might have lost money here, but the delta remains the same, constant. So there's no change there. We still are seeing 1,000 long deltas from our long 1,000 shares. But the put changes, doesn't it? See, remember, when we bought this put, when the stock was at 55, and we bought the 55 puts, they were directly at the money, 50 deltas. But now that the stock traded down $1, our puts increased in delta. Why? Because now our puts are in the money by $1. They've acquired more negative deltas. Higher percentage chance that these puts will finish in the money at expiration because they're already $1 in. Higher percentage chance. Think of that movement, how that colored area in the bell curve has now increased because the stock has moved $1 in the direction that the puts need. So they're already in the money. So as the stock moves down, the put deltas increase. They go from 50 to 62.5. Now that the put deltas are 62.5 times 20 puts, we're now seeing a negative 250 deltas from the puts. So now our total put negative delta is short 1,250. 1,000 long deltas from our stock minus the new short 1,250 deltas of these puts now gives a total delta of minus 250. There it is. Our gamma coming in was 250. That means our delta will change 250 for a $1 movement of the stock. We know that when we're long gamma and the stock goes up, we get longer deltas. But when we're long gamma and the stock goes down, we get shorter delta. How many shorter deltas? The gamma per every dollar. 250 gamma turns into a short 250 delta when the stock moves down $1. That's what's happening there. Say the stock trades down another $1. What do you think is going to happen? If you notice, the mechanism is actually the same in either direction. The actual mechanism of this is the same. Opposite results, but same mechanism. Now that the stock is traded down another $1 to 53, our 1,000 shares is still 1,000 shares, isn't it? Still giving us 1,000 long deltas. But the change that's going to occur is in what? The puts. Now the puts go from being short 62.5 deltas at 54 to now short 75 deltas at 53. When the stock traded down, the percentage chance of these puts finishing in the money has increased. Why has it increased? Because now these puts are already $2 in the money. The chance of them staying in the money has now increased. That gives them a higher negative delta. When we look at our position now, we've got long 1,000 shares, and we own 20 of these May 55 puts, which are now a negative 75 deltas each, giving us a total of short 1,500 deltas from our puts now. Now that our puts are giving us a short 1,500 deltas, our stock is giving us a long 1,000 deltas, our total delta position down here at 53 is minus 500. Gamma times $2. Remember, this gamma represents a movement of $1. We've just moved $2. 2 times 250 is what? 500. And we know that when we're long gamma and the stock goes down, we acquire short deltas. That's how gamma works. Now, do understand that as the stock moves, we know the gamma's moving. This is a static example. I mean, think about me trying to teach you if I'm changing these numbers constantly. This is probably confusing enough. But if I switch numbers on you, you'll really get confused. But remember, all of this information, all this calculation is done for you automatically on your platform. You don't need to calculate this and add it and all that. I want to show you the concept so you can understand the concept. Think about when you were in grade school and you were learning how to, multiply and divide. And you came home with these stupid homework where you got to divide 6,458,000 by 286. You're doing long division. When you got to college, they let you have a calculator. Why? Because once you understand the concept and you understand what's happening, now you can take the shortcut. Use the calculator. Same idea with your platform. I don't want you to calculate this stuff by hand. Are you kidding me? It's ridiculous. I want you to understand how this works. So when you see your numbers of your position on your platform, you understand why those numbers are what they are and how they're changing and for what reason. That way you can have confidence in the number you see on your platform, and you can have confidence in the proper use of that number. You'll have a good idea of what your position is going to do before it even happens. Now, of course, you can even do that on the platform. Well, now what we have to do is talk about short gamma, the opposite effect of long gamma. And what you'll see is short gamma actually operates much like long gamma, just in the opposite direction. The mechanism is much the same. The first thing we have to do is set up our position. Again, we're going to buy 1,000 shares at 55. But this time, instead of buying puts, remember buying options gives us long gamma, we need to sell options to make us short gamma. So what are we going to do? Instead of buying the puts, we're going to sell the calls. We're going to sell 20 of the May 55 calls. That's going to give us a total delta with the stock at 55 of 0. Why? Because we're long 1,000 shares, which gives us long 1,000 deltas, and we're short 20 May 55 calls, which is going to give us short 1,000 deltas. Now, what you have to remember is although a call is a long delta, if we're selling that call, we're going to acquire short deltas. Think about that whole, negative times a negative, positive times a positive, negative times a positive thing that you learned in grade school. If you look at the shorting something that's negative, the call is a long instrument. So we are shorting the calls, negative on the short, positive on the call because it's a positive delta instrument. Negative times a positive equals a negative. That's what's giving us the negative 1,000 deltas by selling the calls. So our position is delta neutral at 55, but we have a gamma position. We've sold options, haven't we? Many of you stock traders out there won't be used to seeing a position where you really don't have a directional position, but we do have a gamma position, which becomes directional once the stock starts moving. So let's take a look and see what happens here, how short gamma affects our delta. Let's say the stock trades up to $56. Our long shares remain long 1,000 shares. We said that no matter where the stock goes, 1,000 shares is 1,000 shares. So these long 1,000 shares are going to give us long 1,000 deltas. The change that we're going to see occur is going to come from our call position. Remember, when we initiated this trade at 55, we said that the 55 calls directly at the money were going to be 50 deltas each. Shorting 20 of them was going to give us a delta of minus 1,000. However, now that the stock has moved $1, we know that our calls, which were 50 delta, are now going to be a different delta. These calls are now going to be 62.5 deltas each. Now, I'm showing you that these call deltas are positive. It's a long instrument. It gives you long deltas. However, you sold them, making you short that amount. Short 62.5 deltas per contract times 20 contracts gives us short 1,250 deltas. So here, we're actually short 1,250 deltas from our calls, long 1,000 deltas from our stock, giving us an overall total delta of short 250. The stock has moved up $1. Our delta has changed by the amount of our gamma. And since we're short gamma, we know that when the stock trades up and we're short gamma, we acquire short deltas. So here up $1, we're now actually short 250 deltas. The stock position did not change. It was the option position that changed. How much did the option position change? By the amount of gamma per $1. Now, you've got to remember that we are short these calls. Because we're short these calls, we're short delta from the options. And that's also going to give us what? Short gamma, being short the calls. Now, what happens here is we now have a delta position of short 1,250 given to us by our short calls, long 1,000 deltas from our stock position, giving us a total delta of short 250. That's how it actually worked. Obviously, if we wanted to figure out what is our delta going to be up $1, we didn't have to go through all this. We could have just looked at the gamma and said, hey, I'm short 250 gamma. That means up $1, I'm going to acquire 250 deltas. And they're going to be short, because being short gamma, when the stock goes up, I acquire short deltas. We could have figured all this out by just looking at this number. I'm showing you how the number works. Easy shortcut to figure out what it's going to do is right there. It's gamma. It's what the gamma is telling us. What happens if the stock goes up another $1? Instead of being at 56, we're going to have the stock trade up to 57. Again, we're going to have the situation where our stock position remains the same. We didn't buy or sell any more stock. Doesn't matter what price the stock is. If we have 1,000 shares, we're still going to have 1,000 shares. However, what is going to start changing, what is going to change here is our option position. The actual stock remains static. However, now our option changes to 75 deltas. Why? We are looking at the calls. And as the stock goes up, call deltas increase. When these calls were at the money, they were 50 delta. Up $1, they were 62.5 delta. Up another $1, these calls delta increased again. This time going to 75. So, what do I have now? Now that the stock is traded up to 57, some things have occurred. Number one, our delta in the calls, remember those short 20 calls, has changed again. We started off with 50 delta in the calls when the stock was at the money. The stock then traded up to 56, and we saw the call delta increase to 62.5. Now the stock trades even up again, another $1. Stock's now at 57. Our calls with the stock at 57 have increased in delta. They're now 75 delta, but we're short them. Negative times a positive is what? A negative. We're going to wind up short 1,500 deltas from our calls now. Remember, this 75 represents percent chance. As the stock traded up, the percentage chance of those calls finishing in the money has increased. If percentage chance has increased, then that means the delta has increased. So here we are at 57. Now we're getting a minus 1,500 delta from our calls. Remember, we're short these calls. That means we're going to be negative delta and negative gamma. Now, we know that up at 57, our long shares are still going to be the same long 1,000 deltas that they were when we established them. When we combine the new delta from the short calls, minus 1,500 deltas, with the long 1,000 deltas from our 1,000 shares, we get a delta of minus 500. That's how that worked. The shares stayed constant, and it was the calls whose delta changed. And that changed the overall delta of the position. Now, again, we don't have to think about, calculate this by hand. We can actually just look at the gamma. We could see that if we're short 250 gamma, that means we're going to acquire short 250 shares for every $1 up that the stock goes. Remember, short gamma acquires short delta as the stock goes up. So all we have to look at is the stock went up $1, $2. The delta, according to our gamma, should change 250 deltas per $1. $2, 250 times 2, 500. And we know it's short because we're short gamma and the stock goes up, it acquires shorter deltas. And there it is right there. That's what's happening. Again, you don't need to calculate this stuff by hand. There's no test at the end. We just need to understand the mechanism. Why is gamma doing what it's doing? Here is why. Then it's just a matter of understanding the numbers, understanding your position. Now, let's look at the other way. What happens if the stock trades down and we're short gamma? Well, position remains the same. We're long 1,000 shares at 55. Those long 1,000 shares represent 1,000 long deltas. Stock trades down to 54. The stock isn't going to change its deltas. Will we have lost money on the stock? Of course we will. We bought stock at 55. It's now worth 54. We'll, however, make money on the short calls, though, right? Because now the short calls will have also lost value. But more importantly, in terms of gamma, they will have lost percentage chance. They will have lost delta. So 1,000 long shares is still going to be 1,000 long deltas, whether up or down $1. We're down $1 in this example. So we're still looking at 1,000 long deltas from our stock position. It's the offsetting short call position which is going to change again. Now, the delta of our calls decreases because when we were here at 55 in the stock, our 55 strike calls were directly at the money and they were 50 delta. But now that the stock is traded down, these calls, which were 50 delta with the stock at 55 and directly at the money, are now what? Slightly out of the money. Their delta is going to drop below 50. In this case, it's going to change to 37.5. Now, don't get confused by that plus sign. The call deltas are positive. It's the fact that we're selling them which is making our position negative. So now, instead of being short 1,000 deltas because we were short 20 directly at the money, 50 delta calls, we're now short 20 37.5 delta calls, giving us a delta on the short side of only 750. Our stock remains plus 1,000. Our calls that were short, each being 37.5 delta, we're short 20 of them, so we have a total of minus 750 deltas in our calls. Remember, we're short them. Gives us a new total position delta of long 250. Remember, we said that when we're looking at gamma and it's short, when we're short gamma and the stock goes down, we acquire long deltas. So, how many long deltas? The amount of our gamma. So we're short 250 gamma. The stock went down $1. We know we acquired 250 long deltas. And that's how we wound up there. Because our short position, via these short calls, became less negative, making us more positive in our position. We can always trade down one more dollar just to hammer this home for those of you that are a little slow. So now the stock trades down $1 to 53. What are we going to see? Our 1,000 shares are still long 1,000 deltas. But the calls are going to change again. Where they had changed a bit going down $1 from 50 to minus 37.5, they're going to go down even more. The call delta is going to decrease more. Why? Because these calls are now further out of the money. They started at the money, 50-50. They lost 12.5 deltas when the stock went down $1. They lose another 12.5 when the stock goes down another $1. So our total short position from our short calls has decreased. It's going to make us even longer. Now, the short delta from our short calls is only supplying us with 500 short deltas. We're long 1,000 from the stock. Now we're only short 500 from our short calls, giving us a total delta position of long 500. So when we're looking at gamma, we have to remember that when we acquire options, we are going to be long gamma. When we're sellers of options, we're going to be short gamma. When we're long gamma, the stock goes up, we get longer delta. When we're long gamma and stock goes down, we get shorter delta. When we have the short gamma, it works the other way around. Stock goes up, we get shorter. Stock goes down, we get longer. So what you really need to remember is more of that action than anything else. The rest of this was showing you why. From a practicality standpoint and applying it in the real world, we need to know this number, whether it's short or long, and which direction it's taking our delta as the stock moves. The value of this, in understanding this, is we can understand what's going to happen to our position before it happens. And that's where people get hurt in the market. They don't truly understand options. They know how to trade them. There's a difference. When you understand options and you understand your position, you understand what can happen if. And when that happens, you can prepare for that potential situation. You could hedge yourself. That way, when the market crashes or the market takes off, you aren't sitting there looking at your position saying, why am I losing money? Or why am I making money? Or I wish I would have known this was coming. If we know how to do this, we'll know what's going to happen to our position, and it makes it easier for us to prepare for it. People don't lose money because of bear markets. They lose money because they're not prepared for a bear market. They don't know how to handle a bear market. That's the difference. These Greeks tell us our risks ahead of time. We need to know them first before we start putting strategies on. Think about it. It's a little too late to buy car insurance after you total your car. You've got to have that insurance ahead of time. You've got to know the risks and pretty much adjust for those risks before it happens, not after. So that's how gamma works. It shows us how our position will change in terms of our delta as the stock moves. We might not have delta now, we might have it later. We might have delta now, we might not have it later. When the stock moves delta, it's gamma that not only tells us to what degree, but it identifies exactly in which direction and exactly how much our delta is going to change.